Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the third lecture of module 5, Technology of Larval Rearing. My name is Professor Gaurav Bhaumik from the Department of Agriculture and Food Engineering, IIT Kharagpur. So, in this particular lecture, the concepts that I will be covering is how to, when we will be designing a prawn hatchery, what are the different site selection criteria that we need to follow, the hatchery facilities and equipment, the components of prawn hatchery, the spawner and the broodstock transport, larval rearing, post larval rearing, and harvest, packing and transport. So, it is like from its initial stage to the execution stage, how a hatchery design has to be performed and has to be designed around. So, when we design a prawn hatchery, it in general development of prawn industry, it really depends on the steady supply of fry, because natural limited source of fry is like it will like that's one of the major reason why we need to go for designing a proper hatcheries, because the natural supply of fry is like limited, and most of it disrupts the wild population and all. Because of that, we need to improve the prawn hatchery techniques, which will require to increase the fry production, which is like one of the major reason. Okay, what are the important factors that need to be considered for designing a farm hatchery? As like the carp hatchery, it's almost the same, but there are certain changes that I'll be discussing in coming slides. First of all, the site selection, the hatchery facilities and equipment that we'll be designing, the knowledge of prawn larval stages, the spawner and the broodstock collection and transport techniques, larval rearing techniques, post larval rearing techniques, and also the fry harvest, packing and transport techniques. So, these are the very important operating parameters and the techniques that we need to follow, we need to like properly consider before we design a prawn hatchery. In terms of site selection, I do not want to discuss it in more details, because we already discussed in the last lecture, if you remember, about the carp hatchery. So, there also major of them, those factors are actually still lies the same for the prawn hatchery as well. Other than that, the spawner source is important, location is important, because in case of prawn hatchery, in case of carp, you can do it in inland water bodies as well, near to the inland water bodies as well, but in case of prawn or shrimp, you have to make it as near to the coastal region, okay, or otherwise you have to mimic the seawater, which is actually doable nowadays, people are doing in different countries, but still it requires a huge amount of chemical demand and all. And so, the location is very important, the climate is very important, seawater quality that you are supplying. Depending upon though the shrimp and the prawns and shrimps, they can sustain the wide range of salinity, but still depending upon the target species, it is better to be in as specific as possible for them to not to have any stress, any physical stress in their system, in their body. So, seawater quality has to be maintained as as less in a range as possible. Availability of electric power, definitely very important, accessibility and the freshwater supply. When we go for the facilities and designing of equipments of hatcheries, if you see the structure, if you see this drawing, so on the left hand side, if you see in the left hand side bottom is the working area with the proper larval tanks are being placed in a regular manner, and at the top you will see the algal tank. So, algal tank is for what? Algal tank is like a feeding tank for them, right? Other than algal tank, sometimes we provide there some like Artemia tanks also, small Artemia production units also, some rotifiers unit also. So what these things do, these rotifiers, this Artemia is like which we call brine streams also. This algae, they are actually feed for your target crop, right? So that feed, this live feed has also be you need to farm in your hatchery as well. Okay, so that can be done. You see then the design in the leftmost figure in its top. There we provided with this kind of live feed installation systems and all. Then there comes this larval tank. In this larval tank, you see like it's a pretty huge, pretty much sized in structure. So here from the post larval stage to fry stage, we try to rear them, and from larval tank, once it reaches to the fry stage, then it is transported to the rearing units or the different rearing units, and in the rearing units we can go ahead with the further production. On the same hand, if you see, or the post larval tanks we call it, rearing units or post larval tank. If you see in the right side bottom, there is a dotted circle. So these are like 5-ton rootstock tank. That is optional because it can be of any design, and we already discussed in earlier lecture material that how rootstock tank has to be designed, what are the consideration and all. So what is done in the rootstock tank, we have the proper healthy breeders, breeders or healthy individuals or healthy, I would say, like parent fishes. We collect them, we nurture them in a proper manner, in a broodstock manner with a very high efficiency, so that once they will reach to their spawning stage, so they will spawn and they will. This is a very important structural design is very important when we go for designing a farm, prawn hatchery. Especially the layout is very important, because each and every structure, each and every farm, I mean like farming inputs and farming outputs, has to be designed in such a way so it will take as less footprint as possible. I'm talking about in terms of space, I'm talking about in terms of transportation and all. So suppose you have a feeding unit which is like very far from the broodstock unit, so your broodstock unit will be at stake, because it has to provide it with a. I'm just giving you an example. So suppose you need to provide we need to provide aeration line. So suppose you need to provide aeration line, or say like any feeding continuous feeder that is available, that you are providing to your post larval tanks. But suppose this electrical line is far away, or suppose the tank that you have, design is very important. Each and every aspect design is very important, where you are where the electrical connections will be there, where what type of aerators has to be provided. The aeration efficiency will reduce if you have a central aerator line, say like central aerator line. From there you are supplying the aeration to the different through the conduit system to different tanks. The farther aeration tank it is, the less the efficiency of the aeration unit it will be. So just to give you an example, like why these small things matters. Okay, so how you have to, when you design, you have to design all these things very very cautiously. Another important thing is like the renewable energy source. You have to think about the renewable energy source when you will be designing a hatchery. Like you have to provide it with the solar roofing, provided with the geothermal energy to maintain a certain temperature in your system. So you can provide it with the so have a proper, say like proper digester you can provide, or where all your bio waste can be thrown, and that from there the digester, this biogas can be generated, that can be utilized it for different purposes as well. So I'm just giving you an example of when you will design a hatchery facilities and equipments, you have to think about all these factors. This is not a standard design, this is only to give you a certain perspective of how it looks like. Okay, so when you will be designing, depending upon the size of the area, land layout, like the soil feasibility, the soil properties, the sloping characteristics, the number of the amount of culture that you require, the amount of tank that you need to design. So based on all these parameters, you will go and design your farm, right? So it depends with the time to time. So just I want to make sure that you will understand the basic amenities that it requires and basic parameters that it involves, that it depends on. Okay. The components, if you see, the larval and post larval tanks, algal culture tanks, air supply line, seawater supply line, and the building and equipment. Seawater supply line is another important parameters that I will be discussing in coming slides, which I haven't discussed yet. So when we go for larval or the post larval tanks, in general the tank capacity has to be around like 1 to 20 tons depending upon the size of the farm. For economic operation, water holding capacity of larval rearing tank has to be in between 3 to 5 tons with a depth of at least 1 meter. Don't make it very deep, not more than say like 1.2, 1.3 meters. So around 1 meter is okay. Post larval rearing tanks are also around 1 meter with a capacity of around 6 to 10 tons are expected. In general, say like in a 3 ton of larval rearing tank can hold around 1,50,000 to around 3 lakh nucleus. Okay. In general, this prawn nucleus. Material of construction: concrete, fiberglass, marine plywood, bamboo or wooden states with the plastic linings, anything like which is depending upon the size and depending upon the capacity and the economic how to say, the capital cost that you can approach. Okay. The slope 5 centimeter for every 1 meter towards the long side, it is better. Tank elevated to 20 centimeter to the floor level for easy drainage, and because it will make a proper flow through the drainage line to so to not to sedimented the sedimented the suspended solid will not be sedimented, it will be definitely go out of the system by the drainage line. 2 meter gap between the 2 rows of tank is very important for workspace. Algal culture tank, the small or shallow tanks, not more than 1 ton capacity of depth of around 0.5 meter. Adequate light is essential for fast algal growth. Material of construction has to be bamboo or the plastic materials. Air supply, aeration is essential in a hatchery to provide ample amount of oxygen and to keep larvae and food particles in suspension. Electrical blower, compressors and also the portable aerators are used sometimes. The seawater supply, in general adequate supply of seawater is very much essential for the hatcheries, and I remember I discussed with you in the very beginning of the lecture that we will be discussing in details about how the seawater supply is provided. So how do you think the seawater is supplied to your farm? What can be the probable techniques by which you can go ahead with this? Here I have already discussed 4 different ways of supplying seawater to hatcheries. I am 100% sure you will come out with thousands of more ways and how different techniques by which you can supply the seawater to your hatchery or to your farms. Okay. These are the general ways of supplying seawater. First, pumping directly from the sea, where you have you can see the food valves are there with the proper filter mechanism so that it will not be choked very easily. So with these food valves, this lying quite deep to the seawater, and then the water is actually it has to be lower than the lowest low tide level. You know why it is, right? Because there should be a continuous supply of water, and the water has to be, the food valve has to be below the water line at any point of time, right? In order to do so, low tide level is the one at which at least water will prevail for sure, no matter what happens, unless until some very rare tsunami event or something. So most of the cases, the lowest low tide level is like considered as the lowest point at which the seawater will prevail at any point of time, and so your food valve has to be below that low water level. Okay. Then there comes the pumping from the sump pit. You can have a proper line in a sump pit where the water will seep through it and which will collect with time, and from sump pit you can just pump the water. What is the additional benefit of it? Like it's like a already filtered water, not 100%. You have to do it again before supplying to your farm though, but still it is like quite filtered because it will go through the stratum of gravel and rocks and it will come to the sump pit. The third method is like continuous, it's like pumping from seabed using the perforated PVC pipes, which is sometimes doesn't make sense actually, frankly speaking. We normally do it like just below the seabed. There will be like perforated UPVC line, we call it. In this UPVC, there is like perforations. In the perforations, we have this small foam. These foams are acting as a kind of filter material. When we suck the water through the pump, through this perforated tubes, the water will come in contact, because first of all the water is getting filtered through the seabed and then through the foam, and at the end the pure seawater you can collect. So that is one way of getting rid of the additional filtering mechanism or the cleaning mechanism of seawater, treating seawater before supplying it to your farm. Fourth mechanism is like pumping from an inshore well. What is an inshore well? You can have a proper structure, concrete well you can develop by the side of your coastal region, and that coastal area, it will be filled with the gravel. So water definitely because of it's a natural phenomenon, the line has to be almost same inside the well, outside the well, and then when you capture the well, depending upon different pressure anyway. So when you capture the water, when you suck the water through this well for your hatchery purposes, the requirement of additional treatment of water is getting reduced. So these are some of the ways by which we normally collect the seawater, but this is not the only one. So if you want, you can definitely design your own way of doing so. So see, in case of the seawater which is coming in, which is if you see with the arrow, the inflow of seawater in the first picture on the left upper side. So it actually has to gone through filtration unit, filtration procedure, right? Sand, graded gravel, then etc. And then at the end it will go, you see the outflow region, so from where it is collected. So the depth of this filter bed has to be around 1 meter, 0.75 to 1 meter in size, so the proper treatment can be done. And with frequently, what will happen, it will get choked very easily, right? Because the sand particles has a very small specific surface area, like in general the pore areas are getting clogged very easily. How to get rid of this clogging? Sometimes what we do a reverse back flushing, we call back flushing or the back washing. When we do the back washing, through the outlet line we connect the inlet and we pump it. What will happen? So because of the fresh water pumping, all the clogging particles, or what are the foreign particles which are the reason for this clogging, they will get out of we can get rid of this clogging particles, and it will go out along with the outflow water bodies. That also we can again throw it back to the seawater. So that's how the back washing is actually taking place. Okay. So we are collecting the seawater through this filtration unit. You will see the seawater reservoir, so tank 1, tank 2, tank 3, tank 4, tank 6, and to the other tanks. It's going this way. You will normally design the distribution channel. Okay. So when we design this hatcheries, the prawn hatcheries, the building and equipment is very important, right? We normally go ahead with the concrete building or a building with the local inexpensive materials like bamboo for housing of the larval tanks and etc. Sometimes what we do nowadays, we do the poly housing also, which actually helps sometimes in the temperate region, because of the poly housing, the temperature inside the poly housing, outside the temperature outside it really varies. So even if the temperature outside is little bit less, the temperature inside will be at least 4 to 5 degrees Celsius higher than the outside, because of the greenhouse effect, right? This low wavelength, high wavelength sunlight phenomenon. Anyway, so because of that, it also sometimes makes sense to design poly houses for this kind of structure, this kind of hatchery design and all. Equipment like thermometer, hydrometer, hemocytometer, refractometer has to be there. Microscope and refrigerator has to be there. Beakers, drainers of varying types, mesh sizes, harvesting box, coop nets. These are the equipments that we need to have in your hatcheries, and all these equipments that you will procure based on the type of environment and the type of uses, right? So it depends. So these are the things that we normally follow. These are the things that we normally collect in our. We normally after designing, we normally put in our system. The spawner and the broodstock transport, which is very important, and if you see in the picture in the left, what is the right time for transport? Definitely in sunrise time or in the sunset times. They are still in the not at its high active stage, and in case of sunlight exposure also, what will happen in case of white day, and what will happen, it will cause some anxiety and additional stress to your broodstock. So that's why it's better to collect them and transport them in a early sunrise or early after sunset time. Okay. So normally it is collected in oxygenated plastic double bags, and then it will be transported from one place to another. Larval rearing, so which is one of the most important part of prawn hatchery, right? So these procedures must be done well for successful fry production, like spawning and hatching, stocking of nuclei. You know what is nuclei, right? Like nuclei, we discussed about it in the very beginning of the lecture, earlier lectures. The feeding, because nuclei is like initial stage of prawn. Okay, so it's their stages of their maturation stage, actually early stage of their maturation level. Feeding and the water management. In order to go for successful fry production, you have to take care of these procedures, right? How spawning and hatching is important. Clean and oxygenated seawater with a salinity of 30 to 35 ppt is required, with a temperature range of around say like 28 to 30 degrees Celsius, and the spawning it will take place between 10 p.m. to 4 a.m. which is in the late night, right? So in the late night is the best time for the spawning to take place, and it lasts for around 2 to 7 minutes. And the eggs hatch into the nuclei from 12 to 15 hours after the spawning. So for this period of time, it's very important. It's very precious time, because any small environmental changes or any small manual error can completely disrupt your farming product. So during this 12 to 15 hours, you have to be very cautious. And once the hatchlings are out of your eggs, then you have to which we call this noplis. So these noplis, you have to take care of it. You have to start rearing them in a larval tanks. Okay. Stocking of nuclei, in general, the rearing tanks properly, we have to clean the rearing tanks, and we stock like 50 to 100 larvae per liter of diesel, say like 1000 liters, so 1000 multiplied by 100. So that many larvae can be easily cultured, or how to say sheltered, or produced in farm in your rearing tank. Feeding, proper nutrition must be ensured for the larva. Algae can be phytoplankton culture, mostly used for food for shrimp and prawn larvae. Other foods like egg yolk, artemia cyst, etc. can also be provided. This is for the larval stage, right? Because for them they need live food mainly, as we already know what is the reason behind it, why we need to provide the live feed, and why they need this live feed, and how they can get more benefit out of it. Okay. Water management, water quality in the rearing tank deteriorate with the deposition of the fecal matter and the uneaten feed, and because they are in a very early stage of development, the fecal matter, their feeding rate is also very high, their fecal matter generation is also very high, and because of that the water quality get deteriorated very fast. Okay. So that's why daily water exchange of around 30% of the total volume is like almost necessary, and which is like really huge. Like you cannot just do it with a regular freshwater exchange nowadays, because or like seawater exchange nowadays, because it will cost you a lot. I'm not talking about the seawater cost, I'm talking about the conveyance charge, I'm talking about the transportation charge, cleaning charge, pumping cost, and etc. So it's a lot of cost that involves with it. So how to get rid of it? Again, I'm telling you again and again, the best thing is the recirculated aquaculture systems. You design it, design a treatment unit, treat it, and treat it back to the water system again. It's like how to say, in situ solution. Like there only you have the solutions ready with it. You don't have to go outside and think about procedures and problems, how to troubleshooting measures and all. Okay. Regular siphoning of the culture tank bottom sediment is very important, at least 2 to 3 times per week. And once it reaches the post larval stage, they transfer to the nursery tanks or the post larval rearing tank to avoid the overcrowding of the fry in the rearing tank, or say like larval tank. and to vacate the larval rearing tank. So, these are the reason why we transfer them. So, it is advantageous to nurse the early post larva in tanks instead of stocking them directly in the nursery pond, because in case of tank you can better control the environment in a very precise way, right. And stocking density of around 3000 to 5000 post larva per ton of seawater is possible with a substrate of bamboo slats, fine nylon materials and polypropylene netting materials can be used. As a feed, we provide the muscle meat, the trash fishes, etc., because they already reach a certain stage. So, for them the very high animal protein or is very much essential for them, and not only essential, like the better the food that you provide, the better the production yield that you will be getting, as simple as that. Okay. Water management at least 4 times a week, around 30 to 50% of change of water volume each day, and siphon of excess feed. That is very important in case of post larval system as well. So, now the post larval system is designed. Now, we need to think about the harvesting of the catch, harvesting of our product, packing and transporting them. What is the standard way of doing that? You just harvest the product by using the netting, or just reduce the water and then collect the product or the fry, and then count them. There is like counting mechanism is nowadays, it is not that earlier, like earlier days we used to do it by manually, but thanks to the technology now you don't have to do that. There is a manual, there is a electronic counting machines which are available. So, you just put the water through it, like so there will be like laser unit. So, it can easily count the number of fingerlings that crosses that particular boundary, and by means of which we can easily calculate the number, you can easily count the number of fingerlings of your system of your farm. Then you pack them in oxygenated plastic bags and then transport it to the styrofoam inside the styrofoam. So, that is obsolete now, not obsolete, like there are things still people are doing that, but there are thousands of other mechanisms are coming out nowadays, and where very enhanced packing mechanisms are nowadays are there, which helps them to be in its stage for long. Okay. So, other than that, we have to, when we transport it, it is better to have a proper the freezing mechanism. We call it this freezing trucks and all that you have to have. So, you can have the proper freezer trucks, or you can have this this ice cube bags and all, where you can also put your inside the styrofoams these ice cube bags to make the proper temperature. Sometimes we supply it with the salt mix, this ice cubes, or we call it ice crust and all. So, that actually what it does, why we mix the salt, to reduce its melting point, right, because in general the ice, it melts at 0 degree. When you add it with the salt and all, it will reduces its melting point after certain further couple of degrees. So, because of that it can sustain for long in its ice stage and all. It's a scientific phenomenon. You can Google it and you can get a better idea about it. And if the travel time is more than 6 hours, these plastic bags are also has to be placed up and down. So, with the air filled plastic bags, which will further give it additional protection from the radiation based effect from from the outer atmosphere and all. So, anyway, you have to make sure that there is no air exchange, there is no temperature exchange, whether it be conduction, convection or radiation, so that the ice can be at its stage for long, and then it will definitely passively help your produce, or passively help your yield product to sustain for longer period of time. So, in general, in conclusion, what we can say, the prawn hatchery plays an important role in supplying a steady state supply of fry. If properly designed, the components of the hatchery can ensure a successful fry production, and this is because prawn is a very high value product, high value species. Natural source of fry are limited, and in order to expand the production of prawn, fry has to be available in abundance, right. And what is the only way of doing it? Is the improved the prawn hatchery design. So we can design proper prawn hatchery, and which will definitely give us a way to collect the fry which is sufficient enough for the supply of or the requirement of all the market and all. Okay. So that's it for the prawn hatchery. The shrimp hatchery, next we'll be discussing about the design of shrimp hatchery and all. This is the reference from which I have taken couple of pictures and the material. So thank you so much. We'll see you in the coming lecture. Okay. Thank you.